Hello and welcome to the 5.5 notes. This is a section about the average value of a function. Now I want to quickly talk about how we kind of get an average value. What I want to first talk about is the average rate of change, okay? And remember that average rate of change is the slope between 2 points. And I want to go back to that problem that we talked about very early on in the year. One of the first things we talked about, and that's Mr. Police's average speed going to work. Okay. And so remember what we did was we took a position graph, and what we knew is that it took 12, Mr. Police lives 12 miles away, this is miles, and we knew that it took him 0.25 hours, okay? And so we had this position function where, he leaves and he stops and he goes and he stops and he goes, and then he goes on the highway for a bit and then stops and goes and gets to his final destination. So remember what we did here to calculate that was calculate the slope between those two endpoints, okay? To find the average rate of change, we just took the line between both of those points and calculated that slope, okay? Now that was the distance, the total distance divided by the total time, okay? And this was the slope between 2 points. And so what we did was we took, 12 miles divided by 0.25 hours, and we get an average rate of change of about 48 miles per hour, okay? And that's the total distance divided by the total time, okay? But now we can ask that same question given a velocity function. Here you're given a position function. So when I wanted to find the average speed or the average rate of change, here I took the slope between 2 points, okay? But remember that the rate at which you travel, okay, we know this. Well, first let's write this, that we know that distance is equal to the rate at which you travel times the time, okay? But if I wanted to solve this for r, okay, I divide both sides by t, so we know that r is equal to the distance traveled divided by the time, okay? And we're looking for the rate, okay? So here's where the average value theorem comes in, okay, where the average value comes in. So I'm going to do average value, okay, and we want to calculate the Mr. Police's average speed going to work. Okay, but the difference is that if we are given the velocity graph, okay, then we have to do things a little bit differently. But we do need to keep in mind this thing here, that the rate at which we travel is the total distance divided by the total time. So if I come over here and if I write, trying to get this all in the same space, if I come over here and I draw a graph, and this is a velocity graph, v of t, and our label is in miles per hour, okay? We still have our x-axis is in hours, and we've traveled 0.25 hours. It takes me about 15 minutes to get to work, and I live about 12 miles away, okay? But if you're given a velocity function, on me going to work, it's a little bit different. Okay, my velocity function means that I reach a certain velocity and then I stop, and then I reach a certain velocity and then I stop, reach a certain velocity and stop. Then I get on the highway and I'm going, for a long time on the highway at a certain velocity, and then I slow down and slow down and get to work, okay? So but this is a v of t graph, all right? And imagine that that's a curved surface, okay? This is my v of t graph. And the question is how do I calculate the distance traveled? Okay, so the distance, okay, remember, the distance is the integral of my velocity function from the interval between 0 and 0.25. Okay, that's my distance. My distance is equal to that, all right? Especially since I'm traveling in one direction, okay? I know that my velocity is positive, so we can calculate the distance. And so if I integrate, you know, this piece here, then the question is, this gives me the distance, but then I divide that by time. So if I wanted to find my average speed, okay, then I take my total distance, which is the integral from 0 to 0.25 of my velocity function, v of t dt, and then I'm going to divide that by the total time that it took, which is 0.25 hours, okay? And so remember that, you know, I know that my total distance traveled is still just going to be 12 miles, but that's that area under the curve, okay, between 0 and 0.25. It's all this accumulated area will give me a total of 12 miles, so we get 12 miles divided by 0.25 hours, and so that ends up just giving us that we've got an average speed of 48 miles per hour, okay? So, you know, here's the reason why I'm showing you these two different things, okay? The reason I'm showing you guys these two different things is because one of them, you're given a position function, and it asks you to find the average speed. Well, given a position function, to find the speed, I got to find the slope of that line. That's miles divided by hours, which gives me miles per hour, okay? If you're given a velocity function and you're being asked to calculate the average speed, then we have to find the area under the curve to give us the total distance and divide it by the total time, and we get the same thing. So it kind of depends on what you're given, but we have this, and I need you to find a place to put this, but we have this thing called the average value of a function, okay? So the average value of a function, and I'm going to write this up here, the average value, okay, is equal to 1 over b minus a times the integral from a to b of f of x dx, okay? And so, and that's kind of what I've done up here, all right, over here, is instead of dividing by 0.25, okay, I could rewrite this whole thing over here as, 1 over 0.25 times the integral from 0 to 0.25 of v of t dt. Okay, and so, we get this, general formula here, but really, what we're doing here for the average value is we are calculating the average y value from the interval from a to b. Okay, and so, that's what we're doing here. We're really just adding up all these different y values and then dividing over that time interval, and then that gives us our average value, okay? So what I want to do here real quick is I'm not going to focus too much on part B. I'm merely trying to calculate the average value of f on that given interval. So I do want to go through this and, talk about this. And so if I wanted to find the average value, okay, of my function f over this interval, then what we could do is we could take the integral from -1 to 2 of 1 plus x squared dx and multiply it by 1 over 2 minus -1, okay? And so what we would then do is we'd come over here and we'd say, okay, really this is just 1/3 times the integral from -1 to 2 of 1 plus x squared dx, okay? And that's just the basis of what I'm trying to do. Let's go ahead and skip part C here, okay? I'm not too concerned about that. For our purposes, for the AP exam, I'm merely just concerned with you guys being able to set this up based off of what we had up here. So, so let's kind of just skip over to the next page. And what I've got here is I have this example where it says, a study suggests that between 1 p.m. and 4 p.m. on a normal weekday, the speed of traffic on a certain freeway exit is modeled by this formula, okay, S of t, where the speed is measured in kilometers per hour, and t is the number of hours past noon. Okay, and it says compute the average speed of the traffic between the hours of 1 p.m. and 4 p.m. Use your calculator and give your answer to 3 decimal places. So what you would do, if you wanted to find the average speed, and this is a function for speed, then what we would do is we would just take the integral from 1 to 4 of 2t cubed minus 21t squared plus 60t plus 20 dt, and we would multiply that by 1 over 4 minus 1, which is going to give us 3. And this is going to give you a value of 65.5. Okay, and this is in kilometers per hour. Okay. And so, you know, guys, this is kind of all I want to do right now. Some of this stuff we'll kind of tackle in class, but I just want you to get the basics of it. And so I'm going to go ahead and stop this video, and that's all I've got for right now, and we'll see you soon. Thanks. Bye.